So what I'd like to talk to you today about is successive ionization energies. And these here are the ionization energies, and they are written in kilojoules. And so if you notice, sodium has this is ionization 1, ionization 2, 3, 4, 5. And what that means is the energy to take off electrons in a row. So this is the energy to take off the first electron, and then this would be the second electron, the third electron, fourth, fifth, sixth, seventh, eighth. And if you notice, this is sort of a reasonable number, 495, and then it jumps to something large, 4,500. And then we have 700, 1,400, and then we go to 7,000. Again, 500, close to 2,000, a little, close to 3,000, and then 11,000, a big jump. And then 780, 1,500, 3,000, 4,000, and then 16,000. We go from 6,000 to 21,000, and 8,000 to 27,000. And so this last group here has a very large jump associated with it. And we want to see if we can figure out why. And this all goes with wanting to be our octet and wanting to be, a complete shell. So sodium, there is some energy involved with taking away this electron. In fact, there's 495 joules or kilojoules to take that electron away. Why do you think it is that it jumps so high to take one of these 8 electrons away? And if you said it's because we're breaking up this complete shell that looks like neon, you would be right. And so taking away the first electron, not so big of a deal. Taking away the second electron, well, now that's a huge deal to take that one away. I skipped down to aluminum, and if you notice, the first electron goes away pretty easily, so that's one of these. The second electron goes away pretty easily, it's one of these. The third electron goes away pretty easily, it's one of these. But what happens when we get to number 4? Well, we have a huge jump because all of a sudden we're breaking up that complete shell. For the third one here, we're looking at phosphorus. And if we notice, the first electron, not so bad. The second electron, not so bad. The third electron, not so bad. The fourth, not so bad. Even the fifth, not so bad. But when we get to that sixth, so these ones are not so bad. When we get to that sixth, all of a sudden, we're at this huge 21,000. And that's because we're breaking up this inner shell. And so just the idea of how important that octet is and how important and how much these elements want to have that complete shell. And so even though we know phosphorus generally adds 3 electrons in order to get to that octet, we still could take electrons away because we can take electrons away from anything. And it's consistent with any time we go into breaking up the full level that's below any valence electrons that we have a huge spike in the ionization energy.